Factor everything. That's what you want to do. That's really almost all there is to this. 99% of the work is factoring. So that's what you want to concentrate on. Remember, step one, factor everything. Okay, let's see how this works. All right, so I've got an example here. I'm just stealing these examples from the book, by the way. So if you want to see sort of live what the book is doing, that's what this is. So I want to multiply these two rational expressions. I've got two rational expressions here that I'm multiplying. Let's see what they are. Let's see what it comes out to be. Guess what my first step is? I'm going to factor everything. So what I'm going to do is go off to the side, basically. I'm going to do this. Draw a little line here. I'm going to go off to the side, and I am going to kind of have scratch work where I factor everything out, right? So 5a minus 5b is, well, I can pull a 5 out of that, so let's do that. A minus b. 2 and 10, not much to do there. A squared minus b squared is a plus b, a minus b. Okay, so then what I'm going to do is I'm going to go, once I know how everything factors, I'm going to go back to my original and replace all the stuff with its factored form. So we're going to have 5 times a minus b over 10 times 2 over a plus b, a minus b. Okay, so now that I've factored, everything is easy. So the way you really want to think about multiplying with fractions is this, right? You can see there's a dot in the middle here indicating you should multiply. The way I like to think about it is more like this. It's just one big old fraction, right? Being multiplied. So you can cancel anything in the top with anything in the bottom. It doesn't have to be in the same rational expression. It doesn't have to be in different rational expressions. It could be either one, your choice. So things that cancel, a minus b's cancel, 5 cancels with 10, leaving a 1 here and a 2 there, and this 2 cancels with that 2, leaving a 1 here and a 1 there. So that leaves me with the only thing left here is 1 in the top and a plus b in the bottom. And I'm done. So notice, once everything was factored, it's basically free. You literally just kind of cross everything out and then you're good to go. So let's see a harder example. I think I got one here. Yes, there we go. This looks a little bit messier, and I have left myself an entire screen to redo this. So we got 4w minus 20p. So I'm going to here we have 4w. This is my scratch screen minus 20p equals, well, I can pull a 4 out of that. That looks like the only thing that comes out. That leaves me w minus 5p. All right, let's see what else we got. 2w squared minus 50p squared. 2w squared minus 50p squared. All right, so that kind of looks like a difference of squares, except 2 and 50 aren't perfect squares. However, I can pull a 2 out, so let's do that. That leaves me w squared minus 25p squared, and lo and behold, that is a difference of squares, so that is going to be 2 times w plus 5p times w minus 5p. And you can see why I have an entire screen for this. These get long. Don't try to skimp on the workspace. You're going to need a lot of it. That's just the way it goes. These are just messy. So we got 2w. That's supposed to be a squared, not a cube. Excuse me. Let's. I meant to write a squared there, but with my handwriting, who knows what comes out? So there's a squared. All right, 2w squared plus 7wp minus 15p squared. I might have to 2w squared. Okay. You got 2w squared minus 7wp plus, it must be minus, right? Minus 15p squared. All right, so we're gonna need to factor that guy. So I think the easiest thing to do here is the AC method, so let's just do that. So we're gonna have 2 times negative 15 is negative 30. And I need two things that multiply to be negative 30 and add up to be plus 7. 1 and 30 is not it. 2 and 15, that's not it. How about 3 and 10? All right, that's promising, but there might be more. 4, 5, and 6. No, that's not it. All right, so 3 and 10. So I want plus 10 and minus 3. So this is going to be 2w squared plus 10wp minus 3wp minus 15p squared. All right, so this is going to be 2w that we pull out of the first two, leaving me w plus 5p. Well, that looks vaguely familiar. And then minus 3 that I'm going to pull out of the second pair, and that leaves me with, or minus 3p, excuse me, that I'm going to pull out of the second pair, and that'll leave me with w plus 5p. All right, well, that's good. So that is w plus 5p times 2w minus 3p. Okay. Great. I'm kind of running out of room here. I think I have enough room on the previous page to do the last one. Yeah. 3w plus 9p. I'll just block off a little area up here. Right, 3w plus 9p. Pretty clearly equal to, I made it just a little bit too narrow, didn't I? It's pretty clearly equal to 3 times w plus 3p. Okay. All right, so now I've got everything that I'm going to replace it all. So this was, I pulled out a 4 there, so that was 4 times w minus 5p over 2 times w plus 5p times w minus 5p times something that I've forgotten. What was that one? That was w plus 5p times 2w minus 3p. So w plus 5p times 2w minus 3p all over 3 times w plus 3p. Okay. Did I do that? Yeah. All right. So let's see what cancels. So again, the work is basically over at this point. Now it's just the easy stuff. So those cancel, 4 and 2 cancel, leaving me a 2. All right, so this is 2 times 2w minus 3p, 2w minus 3p over 3 times w plus 3p. Now, I will say this. It is very tempting to want to multiply everything back out to sort of have a final answer. Don't. It's better to leave it factored. Now, it doesn't matter that much for this class, but when you're actually doing more stuff with rational expressions, you want to leave them factored as much as you can. So if the question is just multiply these, just leave it factored out and don't multiply it back out. It's actually doing more work to make it worse. So don't do that, right? Just stop right here. That guy is what I want to see. Great. Let's see the next example. All right, we got another, whoop, oh, computer, come on. No, not that guy. All right, so we got another basically bunch of factoring to do. But the thing I really want to point out is this is dividing instead of multiplying, and that's basically the only difference. Now with dividing, there is really just one more step. So I want to just remind you of dividing fractions. If I'm doing like 3/5 divided by 7/10, what I'm going to do is I'm going to take the thing that I'm dividing by, so this one right here, and flip it over and then multiply. So this is the same thing as 3/5 times 10/7, right? And then it's cancel, and we get 6/7. Great. We're going to do precisely the same thing. Whenever we are dividing by a rational expression, we simply flip it over and multiply. So it is not any harder, to be honest. It's literally one more step of just flipping. I usually don't even write that step. When I'm factoring it, I just write it upside down with multiplying. So let's see what that looks like. I got one there at the end too. All right, so yeah, I'm gonna do the exact same thing I did before. I'm gonna go off to the side and try and factor stuff. So 8t cubed plus 27. 8t cubed plus 27. I think that actually might be one that I used in my last video, which is funny. I didn't check to see what I was doing in this video before I did it. So this is sum of cubes, right? So this is 2t to the third plus 3 to the third. So when I'm using my formula, my a is 2b, or my a is going to be 2t, and my b is going to be 3. So I'm just going to write down what it is. I'll let you look up the formula to do this if you want to, but of course I remember it. 2t plus 3 times 4t squared minus 6t plus 9. And that 4t squared minus 6t plus 9 looking awfully familiar. I think I saw one of those. Oh, hey, I did. Look at that. So heads up, the bookmakers and me to some degree like to be really clever and make a bunch of stuff cancel. So if you see something like, you know, this suspicious looking thing in your original problem, expect that they're probably going to cancel. Don't like just assume, right? You got to check, but it's probably going to happen. So also, by the way, because I know that this is the second part of a sum of cubes, it doesn't factor. And if you want to see proof of that, feel free to try to factor it and try and use the AC method. You'll find out that it doesn't work. If you try and put it into the quadratic formula and factor it that way, you'll find that there's no solutions to this equals 0, or there's no real solutions. There's two complex ones. And so this doesn't factor. So I will leave it at that, but do check my last video if you wanted to see why that's the case about simplifying and finding domain, where I went over it. Then we got 9 minus 4t squared and 2t squared minus t minus 3. All right, so 9 minus 4t squared, that looks like a difference of squares to me. 9 minus 4t squared. Now this is written in the opposite order of the way we would usually end up writing this, right? We usually do the variables first and the numbers. That's not to say this is wrong. This is right because the negative thing is the 4t squared. But you can't switch the order when you're factoring this. So this is going to be 3 plus 2t times 3 minus 2t. And the reason you can't switch the order is that 3 minus 2t and 2t minus 3 are different things, right? They're negatives of each other, which we're going to use in just a second. And then there was one other one. It was 2t squared plus something minus t minus 3. So we have 2t squared minus t minus 3. And you can do this by trial and error or the AC method. I guess I'll do AC method since that's what I've recommended for you guys with these. So I have minus 6, and I need two numbers that multiply to be minus 6 and add up to be -1. And this is actually an interesting one. I guess it would be more interesting if it was 5, right? So I got 1 and 6 or 2 and 3, and it's pretty clearly 2 and 3. So I want them to add up to -1. So I need -3 and +2. So this is going to be 2t squared plus 2t minus 3t minus 3. And so we're going to pair them up again, as always, with grouping. Pull out the 2t, so 2t times t plus 1. Remember, when I pull a 2t out of 2t, I don't get left with 0, or I don't get left with nothing. I'm left with a factor of 1, because when I'm trying to distribute this 2t in order to get this, I need to have something there to multiply it by, right? So 2t times 1 is how I get the 2t there. I'm going to pull a minus 3 out, and that'll leave me with a t plus 1 again. I'm going to pull a t plus 1 out, and that'll leave me with a 2t minus 3. Okay, so let's go replace everything. All right, so I know that this is going to be 2t plus 3 times 4t squared minus 6t plus 9 over 3 plus 2t, 3 minus 2t. And that's going to be times, I know it's divided by, but remember I'm flipping. So it's going to be times, it was something, I forgot what that was. It was what, t minus 3 times 2t plus 1? T minus 3 times, or 2t, t plus 1 times 2t minus 3, okay. Times t plus 1 times 2t minus 3. And notice that I have flipped it. And in the bottom, I actually know already that this doesn't factor because it's the same as this. And I know this doesn't factor because it's the second part of a sum of cubes. So I'm not going to waste time factoring it. Also, it just cancels wholesale. Right, this whole thing, we want to think of that whole thing as one piece. And hey, look at that. That piece exists right there. Bam, that was easy. All right, so a couple things I want to cancel. 2t plus 3 and 3 plus 2t are pretty clearly the same thing because I can add an annual, right? If I did 3 plus 5 or 5 plus 3, I get 8 either way. It doesn't matter what order I add in. So I think it's fairly clear that these are the same. However, these are not, right? 3 minus 2t and 2t minus 3 are not the same thing. They're almost the same thing. Right? 3 minus 2t and 2t minus 3. All right, so I want to make a point to you here. And the point is this. If I have two things, right, let's say 10 minus 6 versus 6 minus 10. Those are very similar to each other, right? This is 4 and this is negative 4. If I have 100 minus 79 versus 79 minus 100, right? 21, negative 21. Oh, that's terrible too, but whatever. You get the idea. Notice that these things are always negatives of each other. If I just reverse the order I'm subtracting in, I get things that are negatives of each other. So if I have something like this, right? So this is 4 over negative 4. That is negative 1. And in fact, that always happens. If you've reversed the order, so if I do a minus b over b minus a, no matter what a and b are, I end up with negative 1. And the reason is I'm going to factor a negative out of the bottom. A minus b over minus b plus a, right? When I pull a negative 1 out. And that leaves me this, a minus b over negative 1 times minus b plus a is just a minus b. So those guys cancel. So no matter what the a and b are, if I just reverse the order of subtraction, they do cancel, but they don't leave me a 1, they leave me a negative 1. So this 3 minus 2t and the 2t minus 3, if I were to put them in just a fraction themselves, right? 3 minus 2t over 2t minus 3, that's like the a minus b over b minus a. This is negative 1. So when I go back to my original problem, which was somewhere, where was that? It was here it was. I got 3 minus 2t and 2t minus 3, so they do cancel. I just end up with an extra negative. So looks like everything canceled except for this guy, and that's not an exponent of negative 1 at this time. So this is negative 1 t plus 1, and I guess I would probably write this as minus t minus 1. I know I said you don't need to multiply it all out. It kind of makes things worse, but here it feels silly not to. Okay, so let's do one more with 3 parts. So this addresses 2 things. 1, what do you do if there's 3 things? And 2, what do you do if some of those things are not fractions? So here's what you do if they're not fractions. It's very easy. Bam, now it's a fraction. For the dividing, or for the thing with 3 parts, you just handle all the parts individually. We're dividing by 27 over 4x plus 2, so we're going to flip it over. That's all there is to it. If there were multiple divisions in here, we would just flip all of them. Anything divided gets flipped. Not the thing being, not the thing, so I'm not saying it's very well. The 8x plus 4 over 1, that's not getting flipped because that is being multiplied. This is being divided. So the division goes with the thing after it. So the 27 over 4x plus 2 is being divided, so that's going to get flipped. Now, the factoring here is so easy that I don't even really need to bother doing, I don't even really need to bother having another screen right here. I'll still do this. But 2x plus 1 can't be factored. 8x plus 4, I guess that can be factored, right? So 8x plus 4 is 4 times 2x plus 1. All right, that seems relevant. And then the 4x plus 2 is 2 times 2x plus 1. And then everything else is a number, or 2x plus 1. So yeah, I'm just going to rewrite this. So we're going to get 45 over 2x plus 1 times 8x plus 4. Nope. Factored form. 4 times 2x plus 1 over 1 times 2 times 2x plus 1 over 27. And notice, again, I flipped that last one and made it times. And then it's canceling time. Okay, those cancel. And then I've got 45 and 27. 9 goes into both of those. So it leaves me a 5 here and a 3 there. And then I am done. I think so. Okay, so we have a 10 on top. No. No, we have 40 on top. Is that right? Yeah, okay. 40 on top with a 2x plus 1. All over 3. I'm done. You could also rewrite this, by the way, and I bet your book probably does. I think I'd probably just leave it like this, though. That's it. That's how you do these. Let me just remind you of the number 1 rule. Factor everything. Once you factor, it's super easy, right? You can see that once everything is factored, it is obvious what cancels. The number, you just cancel the things in the top with things in the bottom. The dividing really doesn't make it any harder. It's literally you just turn over the thing that you're dividing by. That's it. Like 99% of the work is the factoring. So step 1, do all the work. Steps 2 through finish, just cancel stuff. That's pretty much how it goes. Yeah, that's all I really wanted to say about multiplying and dividing rational expressions, because that's honestly all there is to it. Almost all of the work is the factoring. So yeah, flip over the things you're dividing by, factor, cancel. All right, I'm done. That's all I want to say there. So I will go ahead and see you guys in the next video.